So good morning and Jai Hind. I am Vikash Kumar, Assistant Professor in Mechanical Engineering Department at Akgec Garg Engineering College. So today we are going to discuss topic that I have taken from Material Science, and that is Hume-Rothery rule. So here we are going to define this Hume-Rothery rule. What this rule all about? You can just see this line: to obtain homogeneous solution in binary system. For that particular purpose, we have to apply this Hume-Rothery rule. How we are going to get this homogeneous solution in binary system? As you know, binary system is that where we are going to mix two elements, and whether it is properly mixed in all way or not, that we are going to discuss, and how we become sure, like when we are mixing two elements, whether they are going to mix properly, they are going to make homogeneous solution or not. So if we follow some certain rules that is defined by Hume-Rothery, then we will easily get this homogeneous solution in any kind of binary system. So little more about Hume-Rothery rule. So what is all about? It is for predicting whether one element, the solvent, will dissolve another element, that solute, to form substitutional solid solution. As you know, if we have what is solvent, first we have to understand this, and what is solute. Suppose we are having one element like this. So this is having major percentage, and solute is an element that we are going to mix. Like suppose I am going to mix some other element that I have denoted through some other symbol. So this is known as solute. So what we are talking about here, it is a prediction where one element that is known as solvent, that I have made here through circle, is going to dissolve with an other element that is known as solute. So basically they are going to form substitutional solid solution, and this substitutional solid solution should be homogeneous. For that particular purpose only we are applying this rule. And this rule also states two elements will likely form a substitutional solid solution when these four conditions are met. So here now we are going to discuss what are these four conditions. If we are going to follow, or if that particular condition is going to met, then definitely we are going to get homogeneous solutions in binary system. So here talking about very first rule, the atomic size of the solute atom is within 15% of the atomic size of the solvent. So as I discussed, here it is solute. So this solute, whatever like atom size we are using in that particular mixture, so within 15% atomic size of the solvent. So this size cannot be increased or decreased by 15% of that particular atomic size. Also we can define this in more simple way. Similar atomic radii, if two elements having similar atomic radii plus minus 15% difference, with this difference, if two atomic radii are going to mix, they will definitely create homogeneous solutions in binary system. So here we have to check radii. So first thing we are getting here is radii. Second is similar crystal structure. As we know, there are so many types of different crystal structure like BCC, FCC and other things. So if they are having similar crystal structure, definitely the mixing of these two elements is quite easy. So this is second rule that we have to take care. And next is these two elements must have similar electronegativities. So that we will going to discuss what is this electron negativities. And last one is these two elements must have similar valencies. So this is the fourth rule. So we have to check our both element on these four criteria. If they are properly fit into this criteria, it means we are going to get homogeneous solutions in binary system or perfect substitutional solid solution. So talking more about each and every rule one by one in more detail, like what is the meaning of similar atomic radii? So different cannot go beyond 15%. So here one formula they have given. If you follow this formula, what is this? Percentage different is equal to radii of the solute. So here this yellow color is known as solute. And here this is solvent. This yellow color basically major percentage present here is this yellow element. So this is known as solvent. And this particular element is known as solute. So here we have to check radii of this solvent, this yellow color atom, and we have to check this solute radii also. So for that they have made this formula, radii of solute minus radii of solvent divided by radii of solvent multiplied by 100%. Then we are going to get this thing. Whatever value we are going to get here, it should be not beyond this 15% range. So if our two elements that we are going to mix fit into this criteria, then we can easily say yes, there is good chance of getting proper substitutional solution. So this is one thing. As you can see here, if my solute radii is bigger than this solvent, then here you are saying you can see some bulge is there towards outside. If that is too low, the radii of solute is too low, means here we are going to get this kind of shape like this. Here some bulge is there like this, but there some compression kind of thing is there. So here maybe some tensile kind of force is applied, here some compressive force is applied. So this is one basis. On that we can check whether our mixture, two elements mixture is going to mix properly or not. And for that, if you go through periodic table, all element radii mentioned here, suppose we are talking about chromium. Chromium is 166, and suppose we are going to mix chromium with this nickel. So we just have to check whether it is in plus minus 15% range or not. Maybe we are going to mix with this, just take example of nickel with copper. Again, I am trying to mix these two elements and trying to make binary solution. So you can easily see it is very, very close to each other. So radii is very close to each other. So there is very, very high chance we are going to get proper substitutional solutions. But this is not only enough. We have to check all three parameters also. So this is only one parameters. And by using this table, you can easily relate. You can easily find out whether we are going in right direction or not. Just see, if I am going to mix here F with F with maybe with magnesium, suppose. Can it be possible? No. Here you can say there is lot of difference and that is beyond 15%. So the solid solution or binary solution for these two elements is not possible. So by using this table, you can easily like correlate whether you are going in right direction or not. And second criteria, as we said, the same crystal structure. If the crystal structure is same, then mixing of all these should be very, very easy. Like here, if you see, if I'm going to mix aluminium with nickel, suppose, or any other element with any of this family, then it is very, very easy because they are from same family and having same crystal structure, that is known as FCC. So this FCC can easily replace or can easily mix with other element of FCC. If we are focusing upon this family, here all elements can be easily mixed to each other. So here you can see lot of elements range is given. So you can easily mix any element with any other element. So because of all having this BCC structure. Similarly, for this HCP, you have again few range in that you can play. So mixing any element with this is very easy and you will definitely get homogeneous solution here also and here also because of this crystal structure. So if it is body center cubic structures, you are taking two elements from this family, definitely you will get homogeneous solution. So this is second fundamental rule that you have to follow. Now coming to the again one table you can see here, in that all elements structure mentioned in this bottom, like we can mix these two elements because of same crystal structures. Suppose I have BCT, so I have to find another BCT element, then only I can go for this mixing. So if it is there, then we can do, otherwise the mixing of this element is not up to the mark. So I'm not getting this kind of structure here. Now coming to like any other HCP can be easily replaced with this, can be easily mixed with this, like that. There are so many options we are having. So same thing we have discussed in previous table. Like here you can easily select any two elements and you can start mixing. But before that you also check whether their radii is within limit or not. Now third rule is known as electronegativities. That is known as a property that says how badly an electron wants to steal an electron. So this is the key definition. How badly an element wants to steal an electron. If that property is there, that means there is good chances of getting homogeneous mixtures. And you can use this equation. If that is equal to this 0.3, then we can easily say, yes, it is having this good electronegativities. What we are trying to see, solvent electronegative, solvent minus solute upon solvent. So what is the formula here? As long as the electronegativity difference is small enough that entropy wins, the atom will form a solution instead of compound. It turns out that this difference is about 0.3. So this difference you can check through this formula and you can get the results. And for that also, for making this exercise easy, we have again one table. In that the value of this electronegativity is defined. So here you can mix any item, but it should be having this calculation. If that is there, means we can go with that. So electronegativity, this, you can say 2, 2.02, 2.33, like that. There are all range is given here. So here you can see the color also. We have to focus only metals here. This light color is not non-metals. This you cannot go with this mixing because that is non-metals. Now this fourth rule is similar valency. Similar valency, as you know, valency is a number of electrons that an atom uses when bonding with other atoms. It is closely related to numbers of electron in an atom's outside shell. So suppose you are going to mix with aluminum with this oxygen. So here Al2O3, because here we have 3 valency and here we have 2 valency, that can be easily done. So this valency thing also we have to take care while we are defining this Hume-Rothery rule. So we can quickly revise all these 4 rules by just targeting this problem. See here one table is there and here we are trying to predict, would you predict more this Al and Ag to dissolve in zinc or not? So more Zn or Al in copper. So here we have to check with these two. So here our one element is there and here second element is there. So talking more about this. So here first parameter is our atomic radii. So you can see here it is quite close. If we are going with this 15% different, so it is following that rule. Second was crystal structure. It both having same crystal structure. It means it is also following same. And electronegativity is also very close. And valency you can see here is also okay. So we can say here it can be easily dissolved. If we are going to like cover this thing, just a minute. If I am going to check this with this, so you have to find out whether this difference is within limit. Here if you see this is having totally different crystal structures, so I cannot mix these two elements. If you see this, if that is within range 0.3, then we can go. That you have to check. And again here this valency. So if these 4 criteria, just check if this 4 criteria is followed by any any mixture, any element, then only we can say it is perfectly it can create perfectly homogeneous solution or perfectly substitutional solutions, binary solutions. So before mixing these two elements, you can have an idea whether I am going into right direction, whether I am going to get proper solid solution, binary solution or not. So before that, you should check your all element that you are going to mix with all these 4 parameters one by one. Then only you are having a good idea about this thing. So like binary system are mostly used for like creating any new compound, any new metal, any new alloy. So it is very like you can say it is very essential to apply this kind of rule before you are doing any kind of research or you are involved in any kind of like metallurgical research. So this should be very good rule. So try to follow this rule while you are mixing any 2 elements. So this is all about Hume-Rothery rule. So Jai Hind to all and thank you for listening.